Hello, my friends. All right, let's do this. Let's start this implementation. So the first step is, of course, to implement the data preprocessing phase. And it will be slightly different than what we did before because we will only use actually from our data preprocessing template this code cell where we import, the widely used libraries like NumPy, Matplotlib, and Pandas, and then only this line of code, to load the dataset. And that's it. Then we won't create a matrix of features or dependent variable vector because here we're doing a totally different thing, association rule learning, and we don't have to split the dataset into a training set and a test set because we will directly learn all the rules through the whole dataset. Okay? So right now we just want this first, to import the main libraries, and then we'll get that line of code to import the dataset. So here I'm creating a new code cell, I'm importing this, and then we can load the dataset. However, there is something important you should know about this Apriori implementation. It is the fact that for the first time, we won't use Scikit-learn. Unfortunately, the Scikit-learn library doesn't include some classes or functions on Apriori. Basically, it doesn't include the Apriori model. Therefore, we're not going to use Scikit-learn to train the model. We will actually use another library, which is called Apriori. Apriori.py is actually a Python implementation containing all the algorithm of the Apriori model. And that's what we will get, and use to train our Apriori model here on the whole dataset. But exceptionally, because Google Colab contains most of the libraries and packages pre-installed, but here exceptionally, Google Colab doesn't include that Apriori module. So we will actually have to install it. And this is very good that you see this because you will encounter this situation sometimes, rarely, but sometimes. And so you need to know how to install a certain package or a certain library from the web, from online. Because what we'll do now is we will enter a command, a pip command, which will download first the Apriori file from the internet, through a link, and then we'll install it inside this particular notebook. All right, want me to show you? Let's do this. So we're actually going to implement this right before, importing the main libraries. Usually the packages are installed as a first step. And to do this, we need to start with an exclamation mark, then pip, that's the pip command that allows to install packages. Then, very simply, speaking of installing packages, the next thing to enter here is install. And then you simply enter the name of that library or module that you want to install. In our case, as we said, it is Apriori. Be careful, it is not a priori, it is Apriori, like that. A-P-Y-O-R-I. Okay? So, exclamation mark, pip, install, Apriori. All right, and now let me show you what it does. As I said, it's going to download it first, and then it will install it inside the notebook. So here it is finding it on the web, and very soon we will see in the output the download. All right, there we go. The download is starting now, collecting Apriori, downloading it from the link, and then installing it, and then, successfully install the Apriori. See, it just takes a few seconds. And this is the version of this Apriori package, 1.1.2. Maybe you'll get a different one, if you take this course way after I recorded this tutorial. All right, so good. Now you know how to install a package within Google Colab, but don't worry, most of the packages, and including the deep learning one like TensorFlow, are already pre-installed. Okay, good. So now, let's import the libraries now as we're here. And now let's implement the data preprocessing phase. So let's create a new code cell. Then, as we said, we will just get that first line of importing the dataset in our data preprocessing template, and we're going to paste that right here in our copy, and that's it. That's all we'll get from the template, and now we will adapt and make it 100% customized to the Apriori model. All right, so first let's just replace the name of the dataset here by the right name, which is, remember, market underscore basket underscore optimization. Okay, and now that we did this, let's think of the right thing to do, which is to upload the dataset. Here, all good. So let's click upload. All right, then make sure to find, that machine learning A to Z codes and datasets folder on your machine. And if you haven't downloaded yet, you can download it right before this tutorial at the bottom of the article. All right, so let's go inside and let's go to part 5, association rule learning, then Apriori, then Python, and there we go. Let's select market basket optimization. Let's click open, click OK, and it will load it. And there we go, we have it. Don't try to open it because it is actually very big and Google Colab won't allow you. But, if you want to have a look at it, you can go back to the folder and, just double click it here, right? And you can see it very well and see all the transaction. Okay, so we'll actually leave it like that in case we want to see it. And now back to our implementation. Let's see what we have to do next. So we already loaded the dataset as a Pandas data frame. However, we have to be careful with something. Look at the dataset again and notice something. Notice that, on our previous dataset, the first row here of this index 1 here contained actually before the names of the columns, right? For example, if we take our social network ads dataset in part 3 classification, well, remember this first row here had first the age, the name of the first column, and then the estimated salary, which was the name of the second column, and then the name of the dependent variable purchased. And here in this particular dataset, well, we don't have names of columns because each of these elements here correspond to just different products. Okay, so there was no need to name any of these columns. And therefore, here we need to add something in our read_CSV function to tell that the first row doesn't contain the names of the column. Because if we don't say this, well, actually it will not take that first transaction because it will think that this first row are just the names of the columns. We have to specify this, and the way to specify this, and it's good that you know this trick in Pandas, is just to add another parameter in this read_CSV function, which is header, and we set it equal to none, right? So that we can specify that indeed there are no headers, meaning no column names. Okay, that's what it means. So now you know this, and therefore it will take into account, it will take the first row of this market basket optimization dataset containing all the transactions, and well, thus it will take the first transaction. All right, good. So that was the first step, but then we actually have another big step, and that has to do with the fact that when we will train the Apriori model on the dataset, well, we will use a certain function that is actually called Apriori, and of course that function will take as input the dataset, but the thing is that it expects this dataset to have a certain format, and that format is unfortunately not a Pandas data frame. And therefore we have to recreate the dataset, from this original Pandas data frame so that it can have this format expected by the Apriori function, which will train the Apriori model on the whole dataset. And so now the question is, what is this format? Well, that format is simply a list of transactions. Instead of having the dataset as a Pandas data frame, we want to have the dataset as a list of transactions. The transactions listed one by one with the different products purchased by the customers. And that's exactly what we have to do now. We have to create that list. And the first step to create that list is actually to initialize it as an empty list. Because then, in order to create that list, we will have to populate it with the different transactions of the dataset. And the way we will do this is, of course, with a for loop. A for loop iterating all the 7,500 transactions of the dataset so as to populate it, okay? So let's do this first. Let's initialize that list. We will call it transactions, and we will initialize it as an empty list. All right, so far it's just an empty list, and now we will start a for loop to populate this list of transactions with all the transactions contained in that Pandas data frame dataset. Okay, so as we make that loop, you will totally understand what we're doing. So for then classic iterative variable I, which will take all the values from 0 to 7,500. But remember that the upper bound of a range is excluded. So we'll actually have to go up to 7,501. Therefore, here this iterative variable will go in the range from 0 to 7,501. All right, there are actually 7,501 transactions because we start from 0 and not 7,500, right? We can check it out very quickly. Here we start from 1, and when we scroll down, we go down to, let's see, yes, 7,501. So that's the exact number of transactions. All right, so all good for the range. Now, don't forget the column, and now we begin the for loop. And well, building this list of transactions is very easy. We will just use the append function, which means add, and which will simply, add the different transactions of the dataset one by one. All right, it's a very classic way to build a list. You use the append function to add your different elements one by one. So let me show this to you. Very simply, what we need to do here is take our transactions list, okay, from which we're going to call this append function, which is a pre-built function of a Python list. Python has all these pre-built functions. And inside, well, we're going to add the transaction, but we have to add it in a pair of square brackets because it will contain, all the different elements, all the different products purchased by the underlying customer in the transaction. And this transaction must be created as a list of products. And that's why we have these new pair of square brackets to make that transaction a list of products. So in the end, we're actually creating a list of lists. Each transaction in the big list of transactions is actually a list. All right. And so now there's a new little trick, but which is good that it is a single row for loop. Because now actually we need to do a second for loop to, get all the products of each transaction. So let me scroll back up. The first for loop will go from this transaction to this one, to this one, to this one, down to the last one at the bottom, 7,501. But then we need to do a second for loop, which will loop over the different products in each transaction. So, it will add this product, then this one, then this one, then this one. And since the maximum number of products in one basket is actually 20, I put this first transaction at the top so that we can have the maximum size of the basket, which is 20. And therefore, what we'll do now is the second for loop that will iterate from 0 to 20. It will start from 0 here, that's the index of the first column. And then it will iterate to this one, then to this one, then to this one, up to the final index, which is the index 19 actually, because it starts from 0, there are 20 columns, so it goes up to the index 19. Okay, so that's the second for loop, and that's what we'll do right away inside this append function to add all the different elements in each transaction. And for the transactions that don't have 20 elements, well, that's totally fine. We will still iterate up to the end, up to the index 19, but we will just populate the list with nans. Nans values, which mean empty, so that our model will understand that the transaction here only has 3 products, okay? So we can totally iterate up to 20, and therefore, let's start this second for loop here. Now we need to take another iterative variable, which we'll call naturally j, for j in the range from 0 to, be careful, not 19, but 20, because the upper bound is once again excluded. So from 0 to 20, then what we will do, and that's the syntax in a single row for loop, we have to do what we want to do with this for loop at the beginning, before the for. And what we want to do is just get that product in the transaction, well, from the index 0 to the index 19. And to access this product, well, we will of course use our data set and play with the right indexes to get the right product. All right, so here we need to call first the data set. Okay, and now let's add some brackets to add, the index of the row and the index of the column that contains that product we want to include in this transaction. So first, according to you, what will be the index of the row? Well, that will be, of course, I, because I iterate through all the rows of the data set. And therefore, now we're dealing actually with that particular transaction of index I, which we're appending into that transactions list. And therefore, the row of the data set we are at right now is exactly I. Okay? I will start from 0. It will first get that transaction, then it will be equal to 1, so it will get that transaction, and then this one, etc. All right? And so now we're dealing with a particular transaction of a particular row, and that's exactly the index of the data set we need to input here. And now for the column, which index do you think it's going to be? Well, that will be, of course, that index, which iterates through all the columns of actually the transaction, right? J will go from 0 to 1 to 2 to 3 to 4 up to 19. And therefore, here the index we want for our column is, of course, J. All right, so very good. But now we need to add one final thing. Unfortunately, we cannot directly access the cell of row I and column J in the dataset. In order to access the cell, we just need to add here a dot values, because that's the part of that dataset structure. This is an advanced structure by Pandas that allows to get access to the cells. All right. So good that you know this. And now we're almost ready. We almost have everything. The only thing that's left has again to do with, a certain expectation of the future a priori function, which we'll use to train our a priori model. It is the fact that all the elements in the list must be strings. They must be strings, otherwise the a priori model won't be able to learn the rules. And to make sure that these, values we populate inside each of our transactions in our list, well, in order to make sure that these are strings, we can force it this way by putting that into the string function, str, which will take as input exactly these elements, meaning these products of the transactions. All right, so now we make sure that the products are strings, in actually quotes, and this will give exactly what the a priori model is expecting as the format of its inputs. Good. Perfect. So now we're done with data preprocessing. As I told you, it's a bit different than before, but now you know that for the a priori model, you have to just create a list of transactions and make sure that all the elements in each of your transactions are strings. Perfect. So now let's execute this cell because we're ready. Let's hope we didn't make any mistake. Play, running the cell, and all good. Perfect. It just ran successfully. Now we have this list of transactions containing all the same transactions as in this dataset, but in the format of a list. Good. So now we're going to take a little break because then comes the real big important step, training the a priori model on the dataset. And to do this, we'll call this a priori function that will take as input exactly this list of transactions that is now correctly populated in the right format to train the a priori model on the dataset. So take a little break, and as soon as you're ready, let's implement that next step together. And until then, enjoy machine learning.